Odd Networks is building a platform for anyone to launch their own over-the-top streaming video service. With Odd Networks, you can deploy your own video channel using a Roku, Amazon Fire TV, Apple TV, or other services. Creating a streaming video service with interoperability between these different platforms presents numerous technical challenges, and today's guest, Kris Walker, explains how Odd Networks is addressing these challenges. We discuss the open source projects of Odd Networks, including Thoughtworks, which encompasses the SDKs, stores, services, and middleware. And we discussed the event bus called OddCast. We also spent a lot of time talking about the business model of this company and the general technical challenges of this strange landscape of proprietary over-the-top technologies. Before we get to this episode, a few quick announcements. One, check out Software Daily. This is a project that we are building as the Software Engineering Daily community. It's led by Jeff Tribble. And we're building an open source news and information site about software. I think this is a really important thing that needs to exist in the world. And if you're a web developer working with React.js or Node.js, check out the Software Daily repo, which you can find at softwaredaily.com. Also, go to softwareengineeringdaily.com. Check out how to be a host for Software Engineering Daily. You can find links to the Slack channel. Sign up for the Slack channel. Sign up for the newsletter, which you can get curated content. You can also send me tweets, send me emails. And with that, let's get to this episode after a quick message from today's sponsor. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/SEDaily. Hired makes finding a new job enjoyable. And Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/SEDaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/SEDaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Kris Walker is the president and co-founder of Odd Networks. Kris, welcome to Software Engineering Daily.
Hi, pleasure to be here.
What is Odd Networks?
Odd Networks is a little startup that we spun out of a video gaming company that is a platform for what we think is the future of television, meaning basically video delivered over internet.
And this is called over the top in the case of Odd Networks. Can you explain what that term over the top means?
Yeah. OTT is the acronym that's being thrown around, kind of the buzzword, and it stands for over the top. It's a term that was kind of invented by the cable industry, and the meaning of over the top kind of becomes a little bit more clear when you think about it from that perspective. Over the top is television content or any sort of video content that's delivered over the top of the traditional set-top box. So anything that comes to you via your Apple TV or your Roku or through your mobile that you cast to your television are all considered OTT, over the top.
And this is Odd Networks is a service for launching my own video streaming service via over the top. Why would I want to do that?
Yeah, so there's a few venues out there where content can make its way to a consumer. So the first thing that comes to mind for everyone is Netflix, of course, and then Hulu, subscription services like that. And they have really great premium content. But to make those businesses survive, they have to be on what we call the head of the adoption curve. So they're looking for just the most popular content that's going to be accessible and enjoyed by the largest worldwide audience that they think they can gather for that content. So that's where we see a lot of things like the original content coming into Netflix and Amazon. Hulu's got some really great content. But there's all this other stuff out there that doesn't really have an appropriate home on YouTube or even Facebook for that matter. And these are things like, for example, one of our customers runs a 24-hour poker channel. It's kind of like the golf channel on cable TV, but it's poker and it runs 24 hours a day, and there's video on demand and all those sorts of other stuff for poker fans. They do like game shows, they do broadcasts of some of the big tournaments.
Right, this is Poker Central, and actually this use case is totally iconic of I mean, I encountered this because I used to play a lot of poker, and when I wasn't playing poker, I would be watching it. And in order to watch it, I would always have to either watch something on YouTube, or I would have to flick around through these random channels that, first I'd have to go to the TV guide and find them, and just all these hacky ways of piecing together what was sort of actually a popular vertical. So I think like the idea that, from my perspective at least, you can tell me what you think of this over-the-top streaming verticalized service, is that you have all these long-tail categories, but each category actually is quite robust. It's quite big, and it's big enough to service an entire platform.
Yeah, exactly. That's the idea. We're seeing this a lot with some sports. There's some really great sports channels that do not only live video sports, but they also do video on demand of things like high school and collegiate wrestling. And if you're a high school and collegiate wrestler, that's something you're really, really into. And I don't know if you would necessarily be considered a fan of it. It's just something that was a part of your life for a long time. And they have very, very loyal audiences that will pay a surprisingly high subscription rate to that. And, when I think back to all the things that I've been interested in my life and think about like what I would be interested in watching on TV, if there was something that was catered that closely to me, I certainly would pay the $5, $10, or $15 a month.
With Odd Networks, let's say I'm building a poker channel, for example. Does that mean I'm building an app using Odd Networks, or am I building a channel? What exactly is the development experience?
Yeah, we like to call them channels. When it boils down to it, it's really a fleet of apps that you're putting out there. What kind of makes the modern era of app development a lot different than it was in, say, like 1999, 2000, 2001, is that when the web was blowing up, we had this really sort of beautifully designed protocol where HTML pages could be zoomed around the world, and you kind of had this minimal type of browser that was standardized in a way that it just became really accessible. In the app world, with mobile apps and TV apps, the manufacturers have gotten us as consumers into a position where we kind of have to choose what platforms we want to be a part of, and they're not always interchangeable. That makes things really, really hard for developers. It's hard to standardize across. So if you want to release a channel on a Roku and an Apple TV, and you also want to target iPhones and Android devices, that's really hard. That's a lot of work, and it's really expensive to keep all that up. So what our platform is it's an open source server, which has like a standardized protocol that allows you to build SDKs targeted for all those platforms, but with a lot of similarities between all of them. So you can serve the content out to all those devices in kind of a standardized, sort of more efficient way.
Okay, you said it's a platform for building SDKs. So does that mean that, how do you standardize across that? How do you make it available for anybody to build a new SDK given their own platform?
Yeah, so we have open source SDKs, which we've been getting a lot of activity on, which we're really excited about. And the functionality in those continues to grow and grow and grow. The main kind of standardization is just a basic HTTP protocol. We're saying, so it's sort of like we're standardizing on a JSON format for an RSS feed. and we're saying this is what this feed is always going to look like, so that you can build all sorts of other software around it and use it as a platform for getting content out. So, if there's some sort of feature that you want to support in the future, or something like that, that's not part of the SDKs and hasn't really been commoditized by everyone else who's using it, the capability will still be there for you to do that.
So Roku, for example, or Apple TV, are these platforms open enough to be able to build an SDK on top of?
They are. It's kind of interesting. I mean, even what has historically been considered the most closed platform around the Microsoft Xbox ecosystem, that's on the Xbox One anyway. It's an HTML5 and JavaScript setup, which, yes, there are some proprietary protocols underneath there. They're sort of proprietary to that system, and some things that anyone who's certified to work on it is under an NDA. That's true, but HTML5 and JavaScript are not under an NDA, and that's really exciting because we can build a lot of software for that particular piece of hardware, that platform, that can be open sourced and that can become part of other platforms.
So, with the example of Xbox, did you say it's HTML5 and JavaScript?
It is, yeah.
Okay, so do you have to write specific stuff for how Xbox digests HTML5 and JavaScript, or can you write it for Xbox and it also works for web? Give me an example of writing the SDK for Xbox, for example.
Yeah, so our hope was that we could write an HTML5 SDK and it would work on the web. It would work. The Amazon platform has a way where you can submit apps to their store with HTML5. Most people are using React or React Native in that case. And then the Samsung TVs are HTML5. Opera actually has a really great platform for television connected devices, and that's all in HTML5 using their existing browser technology. So our hope was that we could cover a lot with that. In the end, we discovered that kind of brought things down to a least common denominator that was not optimal for each piece. So we ended up going back into a place where we targeted SDKs to each of the different platforms. Now that means our footprint is a lot bigger than what we had hoped. But the good part of open source is that everyone has a need for one of these things. So if you have an immediate need, the ability is there to just pitch in and start working on it and collaborate on it, which is a really wonderful thing and something that we've really, really, really enjoyed about being an open source company.
What is the standard set of API calls that each of these different SDKs, and for people who don't know, SDK stands for Software Development Kit. I think most people listening know that. But what are the APIs that every kit, whether it's iOS or Roku or Amazon, what do each of these SDKs need to implement?
So we kind of looked at our past experiences in video gaming and also doing other OTT projects. And said, so what are the things that every single device has to do, whether it be like a mobile or an Apple TV or Roku or whatever the case may be. And we boiled it down to a kind of sequence of actions that has to happen, and then a standard type of data that comes through there. So one of the mandates and design goals that we had from the start was that you should be able to basically crawl through the entire API. And it should be a RESTful API, and each of the documents should link to the other documents. So if you can get a reference to one document in the system, you should be able to find links to all the other documents. So, for example, a typical flow for a device would be when the app is booted up, it calls into the server for what we call a configuration document. And in that configuration document, there's links to several view documents. And examples of those would be like a view which defines the menu, a view which defines the home screen, and a view which defines like maybe a promotional screen or something like that. So then the device knows where to get the data to fill all those views. And then it reaches out to get the collections of video and other types of content that are going to go in those spots. It can get those collections, and then the collections have links to the individual videos and so on and so forth. So essentially, if you can get a handle on, at the very least, one of those documents, you can find links to all the others, which again, like going back to kind of the way the web came of age, where each document is hyperlinked to another. It's really, a beautiful design, really, when you think about it, in the sense that not just sort of like the RESTful idea, but HTTP and HTML and the way the whole web grew up, we're trying to bring that back and make all this stuff interoperable.
Are you talking about building a web of video channels that link to one another that is on top of the classic web protocols we have? Or maybe I don't completely understand where you're coming from.
Yeah, well, that's exactly that. I mean, we certainly hope that'll happen someday. In the worst case scenario, we're hoping the way that this platform will be used is in the same way that RSS has been used. The grand idea behind RSS was that this sort of syndication system was going to be able to go everywhere, and machines can communicate, and you could be published anywhere. That maybe hasn't come to fruition, but at least it's made it a lot easier to move content around and provided some sort of standardized ways of moving content data that everyone, who's in the engineering space sort of gets, and then everyone who's in the media space kind of sort of gets. If you're any kind of a techie person, you know what an RSS feed is, and kind of get that concept. So, we found that's true in video too, that if we can standardize that, so there's something called an MRSS feed. So, which is a media RSS feed, and that's typically been used to do video stuff, but it doesn't have some of these other very specific features to doing OTT, over the top video, so a TV connected device sort of thing. So we wanted to bring that into the picture too, but not throw away some of these grand ideas that were there. Now, granted, some of these things may never happen, and that could all be a pie in the sky. But at the very least, we thought it could be a lot easier than it is, and that was our design goal, from kind of the mandate we gave ourselves right from the start, is that let's make this as easy as software engineers. Let's make this as easy as we think it should be. Let's imagine a future where it works in the way that we think it should, and take some steps towards that.
Okay, so I think I'm getting to where a better understanding of where you're coming from. I want to ask you a few more high-level things, and then we can get into the engineering internals of this, but just to get a better idea of the high-level picture. So you're talking about RSS feeds, and for those who don't know, RSS feeds are, for example, how podcasts get distributed. Why do we use RSS feeds to do certain things with the internet when we could be using HTML? Like, I think of RSS feed as just another way of presenting what could also be presented as HTML.
Right. It could. So in the case of RSS, where you're moving, content around podcasts or blog posts or things like that, RSS is very easily consumable by machines. And it's a little harder to write a piece of software to parse through HTML and move that data around. So it makes syndication easier. Not so much syndication.
Oh, so this is basically like bytecode versus the actual higher level language.
Right. So this is a kind of data format that's meant specifically for machines, and kind of disregards humans. So it's for moving media between machines, between content networks, ultimately for a human to view on whatever platform they're viewing from.
And analogously, we can think of Odd Networks as presenting a format that is more digestible to machines with the express purpose of streaming video.
Exactly.
Okay, so what is so today, for example, if I'm using the Poker Central TV app or channel, what does that mean? And if I'm using it, can I change channels? Where does the paradigm of the old world of changing channels and doing things that we used to do with TV channels, where does that break down?
Yeah, that's getting really muddy. So, kind of the way it's been defined recently is that changing channels means changing apps. So, if you're on your Roku, for example, and you're watching Poker Central, and then you want to watch another piece of content, you exit that app, go find your other app from your home screen, and launch that second app that you would like to launch. Alternatively, we are seeing some what are called multi-channel networks. It's sort of a term that grew up out of YouTube, where you have these channels that kind of aggregate content and brands together, and they kind of by doing this, they're able to pool investment dollars, pool marketing dollars, and then more effectively market the content. So it's kind of like a cable channel. So we're sort of seeing in this new OTT world, whether it be YouTube or the TV connected devices, in this OTT world, you're seeing the birth of brand new cable channels, but at a much more fine-grained level than what they would have been with traditional broadcast TV. And these cable channels may focus on, the people who are into crafting. And there may be someone who's on YouTube who has built a huge audience around doing, photo collages or something like that. And they may add them to their multi-channel network, and there would be benefits both for the content creator and for the multi-channel network because of the pooling of resources. So you may be able to change what looks to you. You may be changing channels in the sense that you're changing content within the same app, but not necessarily out of the same niche. You're still sort of in the same niche audience, but there may be a different brand or a different talent that you're watching within the app.
Okay. So I think, one thing you're getting at this was not obvious to me at first because I don't have a Roku or an Apple TV. The experience for these different things is analogous to a smartphone. You open up an app to watch stuff. Maybe it's a Netflix app or a Hulu app, or in this case, a Poker Central app, where it is essentially an app for watching video, or watching video from several different channels. And Odd Networks supports a rich enough object model to have these different channels, multi-channel apps, whatever you want to call it. So, if I write, is it write once, run anywhere? Can I write my Poker Central channel and it works on Roku and iOS and so on? Or does it require some minor configurations between the different platforms?
Mm-hmm. Yeah. So our goal was to be able to write once and run everywhere. That was one of those kind of pie in the sky things that's going to take a lot more time. Incidentally, that's something that even Netflix has kind of given up on. The position that puts you in when you try to engineer something to run on every single platform is that you're then bound to the lowest common denominators for each one. So if something's not supported on one particular platform, you can't support it on another because you want to be able to run everywhere. So we quickly backed away from that and decided to target each device for its strengths and its weaknesses. And so each of the SDKs is targeted directly towards those devices. There's a lot of sort of platforms and devices that we don't have SDKs for yet. And that's why we kind of consider ourselves to be a platform for building SDKs. And then around those SDKs, we've built several sample apps that should serve any kind of general use case you could imagine. So the idea being, at the very least, you should be able to, without any development, launch an app with your brand and your content in it on any one of the platforms where we have these sample apps for yet. And the sample apps are all open source as well, and the SDKs within them. And we're hoping to grow the ecosystem that way, where you can do this with almost zero development effort, and in some cases absolutely no development effort. And then when you really want to dig into it, just kind of like maintaining your website or any sort of other thing that we think right today is very simple and kind of trivial, where 10 years ago it would have been really hard. So maintaining and updating and adding features to your channel on the Apple TV should be as easy as, moving some things around in WordPress, to improve your website, to add add a WordPress plugin or something like that.
Continuous integration allows teams to ship software faster. SnapCI is a continuous integration tool built by Thoughtworks, and you can go to snap.ci/softwareengineeringdaily to find out more. Snap knows all about your Git branches and integrates seamlessly with GitHub. Snap can run your tests in parallel for fast feedback, and Snap allows you to model your build as a sequence of stages, from the fastest tests to the more comprehensive ones. Configure some of your stages to be automatic and some to be manual, in case you want to have more control over your deployment. SnapCI embodies the lessons that Thoughtworks has learned from 20 years of software delivery, the same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareengineeringdaily. Again, to check out snap.ci and support Software Engineering Daily, check it out at snap.ci/softwareengineeringdaily. But this is directly analogous to the evolution that we went through with mobile web, where we said, early on, we're like, okay, we've got all these platforms that are like, you write an app in HTML5 and JavaScript, and it's gonna turn into a mobile app on iOS and Android. And those things never worked for like 10 years. And people kept trying this, and it just failed and failed and failed. And we could not boil the ocean. We just had this cross-platform nightmare. And then Facebook comes out with React Native, and they start to say, you know what, we're going to compromise and have this learn once, write anywhere philosophy. And it sounds like you at Odd Networks had the same realization that if you can compromise and say, okay, we're going to have some notion of portability between these different platforms, but beneath that layer of portability on each platform, we have a domain-specific SDK that gets us the performance that is not bottom of the barrel.
Right, exactly. Yep, the same thing.
Okay.
Yeah, we didn't take it quite as far as Facebook did with React Native, but they're only targeting, two major platforms with that. We've got to look at a lot more. When you go into the TV Connect devices like Roku, for example, like the technology that's on that device is really pretty primitive compared to a lot of the other platforms. It's made to do one thing. It's not really a multi-purpose operating system. So there's a lot more going for it. And, it says a lot when you look at a company like Netflix, and with all the resources that they have, that they made the decision that they were going to start targeting each device separately.
Yeah.
It just kind of turned into a world where that was really the best way forward.
Yeah, it's such a tragedy and such a waste of effort across the developer ecosystem as a whole. But yes, it's too bad that is just the case. But I think that the Netflix thing it makes a lot of sense.
It is, yeah. When I look back at when I first got involved in software, it was like in the early days of the web, and it was just kind of this eye-opening experience. It's like you can build this thing, and it's not really that hard, and it's kind of fun, and you can send it out there, and who knows who's going to be able to see it, and it can be distributed around the world on all these platforms. And then somehow we let that all slip away when we let these platforms grow up with silos between them. It's who knows how and why it happened, but it's kind of the world we live in now.
Yes. So I think we have Steve Jobs to thank. But let's talk about the actual software engineering aspect of this. I mean, this is a huge project, and there's so many interesting things that we could talk about from it. But to get into the actual software engineering, there are several open source projects within Odd Networks. And the first that we can discuss is OddWorks. What is OddWorks?
Yeah, OddWorks is what we call our content server, and that's the thing that actually serves those feeds. The protocol that it serves specifically is JSON API, and we try to follow that as closely as we can, the official specification for that. We're definitely not 100% there, but we're trying to stick to that. I mean, it's really a great piece of work, and it's like one of those things where someone looked at, well, not someone, but a group of people looked at kind of best practices, and the best practices not over the last couple of years, but over the last couple of decades, and kind of figure out how to link media together through a RESTful API. So that's why we made that decision. The server itself, the OddWorks server, is a Node.js application, and there are a couple of reasons we chose that. Number one was accessibility, is that we wanted something that anyone, no matter what your background, you could at least look at the code and make sense of what was going on. And for the most part, with the exception of maybe Python, most engineers can look at JavaScript code, and you may not like it or love it, but you can make sense of what's happening. It's not like one of those really corner case types of languages. So that was there. And the other thing is that it's performant, at least performant enough, or can be optimized to be performant enough because of the asynchronous environment that it runs in. You can run, multiple instances on the same machine and run them all statelessly. So we're not doing like crazy multi-threaded stuff where, you're doing a ton of processing. We're just serving content, and we're optimizing for read. So when you've got an audience out there that's a couple 100,000 people, and an episode of a particular show goes live, and they all want that episode as soon as it goes, then that thing goes out, and you've got this swarming herd of people that are coming in there. Node handles that really well, and it's easy to scale it up, and it's something that we understood well, and we kind of felt like had the largest sort of footprint of developers in the world who would understand how to do that.
Okay, so talking more about what OddWorks is made up of, it's got stores and services and middleware. Can you describe the roles of these three different component types?
Yeah, so we hadn't really fully wrapped our head around that architecture until we released the second version of it. The first version was just kind of a flying by the seat of our pants cowboy coding thing where we had customers to serve. We had this notion that we did want to open source it eventually, but we weren't entirely comfortable with the problem space yet. So it was something we kind of had to work through and learn by making mistakes. And we did that, and then finally got some time to circle back and cover our technical debt. And we released OddWorks 2, and now we have 3, which is coming in the pipeline, which is very, very similar to 2. But the architecture is that each component in the system talks to the others via a message passing system. So we have services that do various things. We have an identity service, which manages user identity. So if there's some user data that you're tracking, like for example, users may favorite a particular movie, they may give a video that they've seen a review, any sort of thing that you could use to give them better recommendations on what they might want to watch, for example. Like all that sort of data is tracked in our identity management service. Then we have the catalog service, and that tracks all of the actual content that's in your catalog. And that's just one place where the catalog can reach out and sync up with another online video provider. Like, for example, you may have a large portion of your catalog in Vimeo, and we can sync over from that API to make that catalog available on the TV connected devices. Or you may have a custom content management system that you built that has an API where the catalog can reach out and sync your content from that and make it available on the TV connected devices. So that's what the catalog service does. And then we have a store. So the store is a very simple sort of key value store that we came up with, where the idea being that you could put pretty much any database that you could think of behind it. And as long as you complied with the API specification, it would work. So so far we have implementations for Redis. There's a Postgres one in there. There's DynamoDB. So the idea being that we're trying the best we can to not have strong opinions about how you should run your system, and give you all the tools that you need to be able to put it together. And while most people who are launching some sort of media property are dealing with a lot of legacy technology that needs to be integrated to. So that's another important point about being opinionated, is that if your opinions are too strong in the software that you develop, it can put you in a bad position when it comes time to integrate with some legacy stuff. And we wanted to make that easy. So it's a very unopinionated framework, but it does provide you all the tools you need, hopefully, to do the integrations that you need to do with whatever you happen to have hanging around.
I think what you say about the back compatibility and the unopinionation mattering then is important, because as time goes on, some of these platforms are going to become deprecated. Some of them are going to advance at faster rates than other ones. And if you have this lack of opinionation, then it will enforce compatibility even as some platforms become older than others. Okay, I want to zoom out a little bit. I definitely want to keep talking about the software engineering, more internal aspects of it, but something that came to mind: how do these apps get distributed, and how do they get uploaded to these different providers? And is Odd Networks doing hosting? Talk some about the distribution story.
Yeah, so there was kind of two directions we could take our business from a business model. And so to answer this question, we kind of have to talk about that, because it's something that everybody has to deal with. So we could either do something like what a lot of the open source database companies do, where you write a database and then you write some tools around that database, and you provide a professional support license to some customers, enterprise customers that would pay for that. We decided that we would run a managed hosted system. So we provide both dedicated instances for our enterprise customers, which we fully manage and support. And we're also releasing a SaaS product, which basically is all the open source stuff with some sugar on top and we're trying to make that as accessible as we possibly can in terms of price, so that anybody can get started with a video channel, and you don't have to worry about running servers and stuff like that. But it is all open source, and it is a platform, and it is designed for anyone to use in any sort of context. It just so happens that our business model is that we're going to be running a SaaS model as well as some enterprise type licenses. The hardest part of this whole business actually is the apps. The server side stuff and moving data around and doing the integrations has actually been a pleasure to work with. But because of this sort of siloed ecosystem that we live in now, which we don't seem to be able to reverse course on this at all. And some of the biggest software companies on the planet have tried. I mean, Facebook is one that really doesn't like this sort of siloed app system. Google is another one. But it's just not turning around. So this is the world we live in, and the one that we have to try to optimize for. And it comes down to, as soon as things are out of the hands of the software engineer. So it is, if you're not able to automate something, it really, really hurts. And one of my favorite quotes and also a famous one from Linus Torvalds, was that the greatest software engineers find a way to get the work done without actually doing the work. And when it comes to submitting apps and getting them into the store and going through the review process and getting the distribution that you need for your business to grow on these app platforms, there's nothing you can do in terms of engineering to make that any easier. You have to do the human footwork, the sneaker network. And it's really kind of unfortunate because it makes it a lot harder to do this no matter what we can do with the technology.
So it's an open source platform, though. So does that mean that if I want to host it myself, I can do that? So maybe I host it myself and I upload, like I build my app using the Odd Networks framework, and then I compile it or use the SDK with Roku, and I can do it all myself, and I don't need to have it hosted on Odd Networks, or I can choose to have it hosted on Odd Networks. Could you disambiguate that for me?
Yeah, exactly. So there's a few use cases there. We have a lot of very big customers that develop locally. So they have the SDK and they're building an app. It's usually like 5 or 6 SDKs when they look at all the devices that they're targeting, and they're building the apps. And what they can do is they can download the open source server, and then put a bunch of static content on it so that developers can get to work before the business has really even flushed out like how the whole thing is going to work. So you can stand this server up in a few minutes and you've got the SDKs in hand and your developers can literally start on day one. And if the developers run into a problem, you can sort of massage the data by hand and it's sitting right there on the server. And the server could be running on your Mac, on your laptop. And you can sort of tweak the data around to get it into a position where it's working in the app the way that you want it to work. And then the rest of the business can kind of be built around that. So, a lot of times something that's frustrating for developers is that you're oftentimes blocked by, larger business decisions. Like, where is this going to be hosted? And, what content management system are we going to use? And we don't know yet. And you're kind of waiting for these decisions to be made before you can move on with your development. One of the really nice things that we've seen about the Oddworks platform is you can stand the platform up on your laptop and away you go. You don't have to wait for that stuff to happen. So that's one use case. And then the other is that, yes, eventually everyone makes a decision on whether or not they want to run it themselves or turn it over to us and pay either our SaaS license or negotiate with us for a larger enterprise instance.
And what is the advantage of using the Odd Networks hosting? Because my understanding was if I deploy an app to Roku or a channel, whatever you want to call it, Roku does the scalability story. What does Odd Networks need to host?
Well, Roku does the scalability story in the sense that they distribute the app to the customers. But the more viewers you have, the more times that RSS feed is going to be requested. And you get into some especially sticky situations in the video world. And we learned this from the video gaming industry, that you have certain times of day or when certain pieces of content that come out that are extremely popular and the system needs to withstand a very high load for a short amount of time. And that's just one use case. There's a handful of these things. There's like weird sort of anomalies that happen in entertainment where you have systems that really take a lot of work and are very stressful to kind of run because, if it goes down, it's an embarrassment to the company, viewers are angry at you and things like that. And you are ultimately responsible for how that, for lack of a better word, how that RSS feed is making it down to those apps. That's not going through Roku's system. It's not going through Apple's system. It's going through the World Wide Web. So, ultimately, it's on the owners of the platform. Yeah.
Right. Okay. So now I'm understanding because I deal with this with my podcast. I have the actual MP3 hosted on a platform called Libsyn. You probably don't even know what Libsyn is unless you're a podcaster, but it's basically a podcast hosting service and CDN where I just upload the MP3 and then I put the MP3 on my RSS feed that is distributed by WordPress, and then I upload the RSS feed to iTunes. And what the end user experiences it as is, I'm browsing through iTunes. It looks like iTunes is hosting this, but in actuality, that's not true. iTunes is just reading an RSS feed that is reading off of a WordPress, or that is a translated version of a WordPress, which is reading the MP3 link that is hosted on, ultimately, Libsyn. And Libsyn is the endpoint that will need to scale up and down based on traffic. And that's why I pay $75 a month to have a freaking MP3 hosted somewhere. Because this is actually a difficult enough problem that I'm willing to pay $75 a month. I say freaking not out of like complaint at Libsyn itself, just at like that's why I pay for it. And consequently, as I understand, that is analogous to why somebody would want to pay Odd Networks to host their channel, because Roku is not actually hosting the content. Roku is hosting the indexing service of the content, it sounds like.
Yeah, exactly. And actually, the content is not flowing through Roku's system at all. So where that's a little different from the iTunes story is that, truth be told, iTunes is probably doing some caching there. just to help on performance a little bit and ensure that the user of the iPhone and the iPad is having a good experience there. In the app world, like outside of distributed content, like anything that's being sold through iTunes, so that you can sell videos through iTunes too. So outside of that content world, anything that's going on inside the app is not flowing through the platform ecosystem at all. So any content that's flowing through your app on an iPhone or a Roku or an Apple TV or an Xbox, all of that content is flowing right over the wide open World Wide Web, and it's not being optimized or helped along by those platforms at all. So that's what we do. We're optimized for read speed, and we look at a lot of things like caching and dealing with the different sort of caching scenarios, which is that's always kind of the one of the crown problems for software engineers is working with caching. So that one gets kind of interesting. But yeah, that's it, is like trying to smooth that all out and make that experience work for both the content owners, in the sense that they can update their content and get expedient updates, and also make sure the whole thing doesn't fall over when you have a very hungry audience.
Okay, so we're already nearing the end of the time, but this is just I want to go into a little more software engineering stuff before we wrap up. So you mentioned this message passing layer. So some of the platform communicates through synchronous REST calls, but the inner guts of the system uses asynchronous message passing. Exactly. And this is a system called OddCast. And maybe you could talk a little bit about OddCast and why you needed to build a message passing system.
Yeah. So that's been one of my favorite projects. And I think we're like one of the only people using it right now, but it's a Node.js library for doing asynchronous message passing. And it was inspired by Erlang. And a few of us at Odd Networks, we like Erlang and functional languages and Elixir, and this whole idea that you can pass a message through a system and how that message arrives at its destination is totally opaque to you as a developer, and you really don't have to care about that. It's a wonderful thing. You could send a couple of data attributes that would instruct a function to perform some task, and that function and where that task is performed, it could be in the same thread on the same machine. It could be in a different thread on the same machine, or it could be on a different machine on the other side of the world. That is, to you as a developer, you don't know how that works, and you don't have to care. And that opens up a whole world of possibility when it comes to like sort of plugging things together and building plugins that work. Because, for example, you could say, well, we have this gigantic legacy database, and there's no way we're going to get this thing moved over to this other sort of more update technology. But if we write an adapter for OddCast, we can, it will sort of automatically and transparently just shove all of that data into the Odd Networks catalog system, and we'll make that available out on the devices. So, for example, the adapters for OddCast run over, you could build them for any protocol, but we have one for the AWS system that sends messages through the simple notification system, the SNS system, as well as the simple queue system, Amazon's guaranteed queue. And then we pass them around the local system. So if you've got multiple instances running on different threads, different processes on the same machine, we'll pass messages between those things, and that makes your whole system sort of stateless, in the sense that it forces all the developers to work in the sense of like, I'm sending this message somewhere and I don't know when it's going to arrive, and if it will succeed successfully, but it doesn't really matter. It's kind of up to the other system, the system that's going to receive this message.
And I think this fits in nicely with the manifesto of OddCast, which suggests that MVC and object-oriented programming do not componentize our systems well enough, and that we should instead look at CQRS as a way to break up our systems. I know we're up against time, but can you just explain what is CQRS? How does this contrast with MVC and object-oriented programming? how does it improve upon these problems of synchrony?
Yeah, so CQRS, I should say that stands for Command Query Desegregation. So Command Query Separation, I think, is the actual.
Or is it command query responsibility segregation?
Yes, that's it. So it's, these sort of big brains in software kind of started flirting with this idea. It was Martin Fowler who actually put it down in words and wrote up a blog post about it. So if you're interested in learning more, look up CQRS, followed by Martin Fowler, and there's a world of information there. But the idea was that you have MVC systems, model view controller, where the models are performing two functions, and they contain the logic for how to write data into the system and persist it, as well as logic for how to read data from the system. And the problem that software systems run into when they start to get more mature is that when you read data from the system, you're often reading what's called derived data, which is a lot of other information. Like let's take the example of a video. When you view a video on your iPhone, and you see the title and the thumbnail, and you see the description and maybe some user ratings, that's not one record. There's a lot of records there. There's the record of the user. There's a record of all the user ratings that are associated with that video. And then there's probably some recommended videos that come along with that. Those are all so that view that you're looking at on your screen is comprised of a lot of records from potentially a lot of different places. And we were always trying to jam that entire bit of logic into this model. And we're like, so which model should be tracking the recommended videos, and should this whole thing be a view, and how does that all hook together? And it gets to the point where the technical debt starts to build up. The system gets hard to work on as it gets mature. So if you break these all up and you sort of force them to communicate with each other through these asynchronous message passing systems, then you basically write a design constraint into the system which disallows you from putting yourself in a position where the technical debt is built up large enough that you just can't kind of keep up with it. So in order to separate the models into two kind of categories, ones that read and ones that write, you have to have this message passing system in order to keep everything in sync. So the read side, the stuff that's doing the queries, the index table, for example, if you've got your recommended videos for a particular video all indexed on a table, so you can read them off fast, which is you have to do. You can't read recommended videos out of a recommendation engine fast enough if they're not indexed. So they're in a fast read index. That index has to stay updated with, if that user happens to like another video, it's probably going to change what their recommended videos are. And so eventually that message has to make it into the recommendation service that's then going to update that index. So the next time that person views that page, or maybe while they're still on that page, they're going to see new recommended videos coming in based on a new rating that they gave one of their videos.
Okay, that's a reasonable place to stop. We have so much more that we could have discussed. We'll certainly have to do another episode about odd networks at some point in the future. So if you're listening to this and you want to create your own channel or app on one of these over-the-top services, you should check out oddnetworks.com. Kind of makes me want to make a Software Engineering Daily video channel. That would be pretty cool. Okay, yeah. Chris, thanks for coming on the show. I think they will. And this project is clearly very popular. It's catching some crazy popularity. So, Chris, thanks for coming on the show, and thanks for working on such an interesting project.
Thanks so much, Jeff. It was a pleasure.
SafeGraph is building a company to securely monetize exhaust data. If you are amazingly entrepreneurial, you live in San Francisco, and you want to be one of the first 5 employees at SafeGraph, either as an engineer or a business development person, check out safegraph.com.
Wow.